last problem. In this last problem in E, we are going to rewrite this as f of x equals the square root of x minus 3. Remember, f of x and y mean the same thing. So I'm going to replace that f of x with y instead. Equals the square root of x minus 3. And just as a reminder as to what this graph looks like, remember it's the square root graph shifted to the right 3 because that 3 is in the inside, so it should look something like that. Half of a parabola on its side shifted to the right 3, which is why they listed its domain as x is greater than or equal to 3, because the graph doesn't even start until 3 and then continues on forever. So they actually already did something kind of nice for us. They actually already told us that the domain is 3 to infinity without even needing to look at the graph. The equal to and the fact that the graph starts at 3 means we're going to have a bracket. Now, without even looking at the inverse, we now know that I should know the range for the inverse. Remember, domain becomes the range. We're switching our x's and y's. So without ever looking at the new inverse, we should know that it's going to be 3 to infinity. And I can do the same little trick for the range as well. Notice that the range of this graph is that it starts at the middle and keeps on going up forever. So it starts here at a y value of 0 and keeps on going forever. So its range of the original function is 0 to infinity. Again, the graph does have a point there at 0, so it should be a bracket. Now the range is going to become the domain of the inverse. So our domain for the inverse should also be 0 to infinity. Okay, we're almost done here. Now let's find the actual inverse. It does pass the horizontal line test, so we should be able to find the inverse by swapping x and y's. So what that will look like now is x equals the square root of y minus 3. So remember, we've got to solve this guy for y. How do I get rid of the square root? Well, to get rid of the square root, we're going to do the opposite. We're going to square both sides. So what that does is gets rid of the square root with a squared. So now what I have is an x squared equals y minus 3. So to get the y by itself, I'm going to add 3 to both sides. Okay, which gives me that my y equals, let's see, because the 3's canceled out, x squared plus 3. However, we know that this x squared plus 3 is an entire parabola. Our original graph was only half of a parabola, so there's something that's not quite right. I can't take half a parabola and somehow turn it into a full one. And that's why we did the domain and range first, is because we should only be looking at half the parabola, and this already tells me which half. It tells me that we should only be looking at the right-hand side, because this parabola, the x squared plus 3, means that the parabola has been shifted up 3. And looks like this, but we only need half of it. Which half, according to the domain we already found, is the right-hand side. So what we need to do is something similar to what they did in the original, where they had this x is greater than or equal to 3, except for we already know what it needs to be. It needs to be that x is greater than or equal to, well, according to the domain over here, it needs to be greater than or equal to, the value was 0. So be careful. When you're limiting your domain or range on the original, you're most likely going to have to do that in your inverse as well. And it's a good idea to find your domain and range and swap them so that you already have the answer and you don't have a panic after the fact. But we're done. Now, what we're going to look at is how to